All right, welcome. So in this tutorial, we'll be kind of reviewing sources of jitter and how to fix it. I made this project, which I'll link in the description below, but I do encourage you to download it and play with it yourself because one of the issues is with OBS and YouTube, I can only record at 60 FPS, and one of the issues is that frame rate differences are going to cause some of these jitter issues. So I don't know how much it's going to come across in the YouTube video. Probably the more egregious jitter will be more obvious, but it's possible that just from the recording speed, you're not going to see everything that I'm able to see on my monitor. So one of the biggest issues with a source of jitter is, a lot of monitors are have a refresh rate of 60 hertz at the moment, and right now the Godot's default physics tick rate is 60. Which means that the FPS it's going to run at in either the process function or the physics function is going to match perfectly your monitor's refresh rate. So you're not going to necessarily know that there's a problem with jittering unless you have a higher refresh rate monitor or your physics tick rate is lower for some reason. Let's say you're only using 30 FPS for 30 frame tick rate, for example. So the quickest solution to avoiding any issue is just going to project settings and setting your physics tick rate. So just make sure you have advanced settings on. You can search for physics, and under physics common, that's your physics tick rate. And then you can also search for FPS, and it should be under application run. And there's where you can limit the max FPS. Although you can do it in code as well, and the documentation has where to set the limiting FPS. All right, but we want a better solution so that people who are playing at higher refresh don't see the issue. So let's have a look at jitter, for example, for a minute. And let's take a look at our project first. So right now I have this sort of panel up here. Basically all that's going to happen is that this guy is going to slowly scroll to the right, and we're going to try and see if we can see jitter issues with that. The button panel has a lot of settings to change settings in runtime. Most of these settings or in fact, all the settings are available as project settings, so you can set them for your project once and not have to necessarily change them or set them with code later on. But just for the sake of example, and so you can change things on the fly, I have this panel set up, which is going to change the runtime variables. But they're all basically the same. All right, so let us get into this. All right, so I'm going to play the game, and right now my player is moving in the process function. And you can see that the process functions and the physics delta time are a little bit different. And that's because the process function, because I have a 75 hertz monitor, is ticking along at 75 frames per second, whereas the physics is stuck at 60. And you're not going to see much of a difference because the player is moving at 75 hertz, and because the player's movement right now is in the process function, it's moving along at 75 frames per second, and the monitor is refreshing at that rate. So I'm not going to see much in the way of jitter. Now, if you do look, there is something, and we'll get back to that with the round camera position function later. But you will see a little bit of funkiness if you slow the speed down. You'll actually see these rectangles sort of all vibrating. And why that's happening is because of fractional camera positions and I think floating point error. That's that little issue. And you can actually see it if you pay attention and you speed it up. Even if you're going at a faster rate, you can see that there is a little bit of that issue with vibration when the player is speeding along, even when it's in the process function. But let's move the player in the physics function, and you can see that the problem gets vastly worse if we move the player in the physics process. And again, that's because of mismatch between my monitor's 75 hertz refresh rate and the background and the physics tick rate. There's a good article. I encourage you to read it, and I'll link it in the description below too, about jitter in Godot, and it'll sort of explain some of the reasons why this is happening. But essentially what's happening is when the physics tick rate is different than the monitor's refresh rate, and the camera is following the player, then everything's sort of supposed to be moving along at 60 frames per second. But because the refresh rate is going faster, it has to suddenly catch up the visual element to that, and that's where you're going to see that horrible looking jitter. And let's stop. Let's hit play again. And so let us move the player along, and you can see there is that little issue with the rounded vibration. But if we move it faster, we don't see it. But the minute that we select Move Player in Physics Process, you can see the jitter gets pretty horrendous. And you can see that too is if we fix the camera position. So let's pick a stationary camera and we'll reset the player position, and you can see how jittery that icon looks. Just going along, it's really shaking back and forth as the visual element sort of has to catch up. Whereas if we don't move that in the player process function, the jitter is, well, it's still there, but it's at least somewhat less noticeable. It's pretty noticeable anyways. So what's the fix to this? The best fix is, since Godot 4.4, is this setting called Enable Project Physics Interpolation. So let's go ahead and do that. So let me switch us to our non-stationary camera. So now we're moving the player in the physics process. Everything is terribly jittery. And the minute that we enable Project Physics Interpolation, everything gets a little bit better. And there's still a bit of shaking, but I think some of that is also stuttering is also due, unfortunately, to windowed mode. So Microsoft will have this issue where Godot on Windows gets a lower priority. And so if you're seeing a lot of jitter still, make sure you switch to exclusive full screen mode. I think I have a little bug in my project if I click the exclusive full screen mode too many times too quickly. But if you switch to exclusive full screen mode, and we'll move the player in the physics process. Here, let's just move the speed up. And you can see there's a decent amount of decent amount of jittering happening. But the minute that we click enable the physics interpolation, then Godot's going to do the heavy lifting for you to smooth things out. There will be the occasional hiccup, so it's not perfect, unfortunately, but it does significantly improve the smoothness, especially in Windows. I think Linux does not have the same problem. But as you can see, if you just give it a second, it is running very smoothly. But the minute that we turn off the interpolation, you can see there's a lot more jitter happening in the project. So, and you can see that for yourself when you run it yourself, especially again if you have a high refresh rate monitor that's not set at a setting that's a perfect multiple of 60. And I encourage you to do that when you're testing your games to make sure that things are looking smooth for people who aren't there. All right. So the next thing to look at after enabling physics project interpolation is there is this idea that you have to also set the camera physics callback. I haven't actually seen that matter, and I'll tell you why I think that is. But for instance, if we look at the camera function, so we come down here to our camera, and we look at the process callback, there's these two settings. One is idle and one is physics. And switching that changes where the camera process function is run. Is it run in the physics process, or is it run in the regular process function? And that's hence its callback. But I haven't actually seen it matter once you enable physics interpolation in the project. So again, let's move the player speed a little faster. We'll move it in the physics process. We'll see a decent amount of jittering happening, and then we can enable it. Oop, what is happening? Looks like it takes a few frames for it to set in, but there we have smooth movement. But as you can see, it doesn't seem to matter whether you place the callback, where you place the callback in there. And again, I am seeing a little bit of that, and I wonder if OBS in Windows is having issues. So I'm going to switch to full screen mode, and I am not seeing the same issue anymore. But again, it doesn't seem to matter whether you toggle which callback you use. And I think some of that has to do with the fact that when you have physics interpolation on, you can actually see that all of the nodes have this new thing called physics interpolation, and they're all set to inherit. And because my camera is set to the player, and the player is a parent of the scene, and the entire project's physics interpolation is set to on, I believe that's all cascading down, so that's why the camera is sort of automatically getting that. I think if we had a camera that wasn't necessarily part of a scene that was there, we might see the difference, but I haven't played around with that. So just realize that you might have to make that setting if you aren't, but if everything works fine just by enabling the project physics interpolation, then maybe you're done there. All right, so there was one other sort of little issue, and that is if we hit play, you can, and we may move the character really slowly, you can actually see that these yellow and purple rectangles are kind of vibrating back and forth compared to the background. And actually, if we look at the background mountain too, it's actually shaking a little bit too. It's just because it's so big, you're not seeing it as noticeably as these. And they're also, interestingly, vibrating compared to each other, right? In theory, when the icon moves, as it moves just slow steps at a time, really everything in the background should move completely stuck to each other, right? These aren't all these positions are just being updated by one, so or some fractional value of that. And so we should all see them moving at the exact same rate. The camera's just panning them over to the left since we have a stationary object. But we're not really seeing that. What we're seeing is that they're all moving a little bit in relation to each other. And actually, if you speed it up, while it initially looks okay, although that's shaking up a storm. And again, I'm not even moving my player in the physics process for that to happen. And it won't matter whether I do or don't, but you'll see this like vibration. And I think that mostly has to do with if the camera is at a fractional position, it struggles with where to place all those objects perfectly. And so you'll see them get offset. The renderer will place those objects on the screen in a little bit different from each other each frame. And so you'll see it wobbling as you pan. So the solution to that is to actually round our camera position. So let's look at that code really quickly. Where is my code script? So if we look here at what round camera position does, it's just a checkbox, and here's the callback to round, and it just turns on this Boolean. And if we look down at the two processes, here's regular process and here's physics process. When you toggle that move player in physics process, it just stops running this code in the regular process and starts running it in the physics process instead. I do have this teleport button too, and we'll just talk really briefly about that towards the end. But really, what round camera position does is if that Boolean is set by the checkbox, then it does an additional thing where it sets, remember the camera is right now following the player, so wherever the player is, the camera's just moving along with it. But what it's doing is it's saying, hey, I don't ever want to be at a fractional position. So I'm going to take wherever I'm at now, which will get updated by the player after the player is moved, and just move it to whatever the nearest rounded number is. So it's always a whole value. And so let's see what happens when we do that. So let me just play the game again. And we will set the player to, again, it's not going to matter whether we move in the physics process or not. You can see that sort of wobble is there, whether we move in the physics process or not. There is a little bit more jitter if we don't, but if we move it in the regular process compared to the physics process. But you can still see, even in the regular process, these things are wobbling around. Whereas if we round the camera position to a whole number, now you'll see that things move a little bit more in a chunky way just because we're at a really low FPS. So we're seeing the camera sort of move one pixel at a time, or at least what it's really doing is scrolling the background one pixel at a time. And you can kind of see that it's not the smoothest movement because we're just moving it so slowly. But all of a sudden, the wobble is gone, right? These yellow and purple rectangles are not wobbling compared to the background. And the background edge is just consistently moving pixel by pixel to the left. And so that can fix some of that wobbliness if you just avoid fractional camera positions. And certainly as you increase the speed, things will look really buttery smooth because now because it's moving fast enough anywhere really past 15 or 20 FPS, your eyes aren't going to be able to detect that frame by frame movement, and it'll turn into a smooth image. And the faster we go, of course, the faster that happens at. And even if we move in the physics process, of course, we're going to get jitter again because we haven't set the physics interpolation. But with all three of them set, by rounded camera position and moving all those, we get very smooth motion, and you're not seeing that weird slight visual vibration that you can that can happen at fractional camera positions. So consider rounding it. You will run into some trouble, especially with diagonal movements. So it's not a complete it's not a complete panacea of fixes. The other problem is if your player is moving at slow speed, you're going to see that kind of chunkiness if you round the camera position to the movement. So you kind of have to pick your poison. Do I want weird wiggle in my sprites, or do I want a little bit of chunkiness to my movement if I round the camera position? So just be aware of that. But again, I encourage you to kind of play with these things. I forget if we talked about I think we already talked about the enable camera position. Stationary camera just is exactly what it does. We can see if we have a stationary camera, we can see how moving sprites are affected. And again, in this case, rounding a camera position, my code is not perfect since the rounded camera position is going to follow the player. But with a stationary camera, obviously, it doesn't matter if you round anything, right? Because it's not moving anywhere. But that will allow you to sort of see the jitter if you're moving in the physics process and you're kind of going fast. You're going to see the sprite kind of jittering around. But if we enable project physics interpolation, you'll see that it really does smooth out, although it seems like it does take a few frames for that to fix itself. And again, I think in exclusive full screen mode, just realize that that's probably the way you want to have your players play Godot games, because at least on Windows, and I don't think, like I said, on Linux, see now you can see it's really buttery smooth on exclusive full screen mode. Well, maybe not perfect, right? It's not perfect. And I don't know what the full issue is with that, but you can see it's definitely better than it was. Let's see, where was the? Oh yeah, here. If we move the speed up. Although even in exclusive full screen mode, it does seem to help. The regular engine jitter fix does seem to do a pretty decent job. Yeah, you can see if we move it in the physics process, it gets a little blurry because it's shaking really fast, and that's because it's moving quickly. Whereas if we slow it to just the right rate, the jitter will be pretty awful looking, depending on the player's speed. But you can see it kind of gets a little bit vibraty and not so smooth. it almost like blurs the image a little bit because of how fast it's vibrating compared to the background. Let's see. So you can definitely see to your own eye, just flipping that setting to enable physics interpolation on the stationary camera, how much nicer the image appears and how much smoother it is when it's not sort of vibrating at a high frequency. All right. Yeah. See, I don't see really any difference with enabling the camera uh, callback. All right. So yeah, not too long in a tutorial, but I encourage you to kind of play with different monitor settings on your game and play with a little bit of these settings and see if you can see the differences when you enable different things, when you use exclusive full screen mode versus non-exclusive, and see how that affects, especially Windows games. I haven't necessarily tried it on Linux. Just to show you about the rounded camera position, though, I actually was curious about whether that was just an issue in Godot or if it happened in Unreal too. I don't really know how to use Unity, so I started looking, and then it just became too much work, and I don't really ever want to learn Unity, so I did that. But if I do the same sort of project, and well, let me stop it in Godot here so that I'm not overburdening my computer. You can actually see that when you do the same exact test, this is using an orthographic camera, or I think I set it to orthographic, or maybe I didn't. Wait 1 second. So yeah, it's perspective, but it doesn't actually matter whether it's perspective or orthographic. If we look at Unreal and we do a slow camera movement, you can actually see the same sort of wobble too at fractional camera position. So I haven't actually tried rounding this one to whole numbers, but it would be an interesting setting. But you can actually see it has the same issue where it's kind of wobbling. I don't know if you can, if it's showing up on your end, but you can definitely see it kind of shaking along there. And if you increase the frequency, that's fine. You'll make that vibration much faster, but it'll still be there. And now that I've seen it too much, it's like hard to unsee it. But it is there in Unreal as well. All right. Hope this was at least a little bit helpful. And again, go ahead and look at that, download the project if it's helpful to you, and you can look through the code as to how you can change those settings, at runtime versus at not. And just to briefly go over the project, these are just all the buttons. These are all the callbacks. I'm just using lambdas as a quick way of doing that, and just deciding various things based on whether or not the toggle is on or off. I think the only one that's a little bit I can talk about really briefly is, for instance, if you do the stationary, when you toggle it on, I just set it to half the viewport width and height, so it's in the middle. But otherwise, we reset it to back to the player position. I don't think there's anything else that's too complicated. This is just setting the callback, though again, I didn't see a difference, but probably because it's an inherited value. And anything else, this is just changing the speed factor based on the value of the slider. All right, happy coding. Hope this was helpful.